Diaphragm first stage. In order for the second stage to function correctly, it must be supplied with air at an adequate intermediate pressure. The function of the first stage is to regulate this pressure. MARES produces regulators that use a balanced diaphragm first stage. Because of their simplicity and high performance, the first stages on MARES regulators today represent the benchmark product across the sector. Let's take a closer look. The air coming from the tank passes through the sintered filter, which traps any impurities that the air may contain. After filtering, the air passes into the high-pressure chamber, where the first stage valve is located. From here, it enters the balancing chamber, and then the hose heading toward the second stage. The pressure increases, acting simultaneously on the first stage diaphragm. The diaphragm flexes, thus transmitting the movement to the first stage valve, which in turn interrupts the flow of air. The pressure reached inside the balancing chamber is called intermediate pressure. The value of the intermediate pressure is determined initially only by the load from the main spring. During the dive, this will also be joined by the hydrostatic pressure, which is equal to 1 atmosphere for every 10 meters in depth. In MARES first stages, a diaphragm separates the balancing chamber from the outside environment and from the main spring. During inhalation, air flows out of the balancing chamber and the intermediate pressure decreases. It is the diaphragm that, by flexing, opens the valve and allows air to flow until balance is restored. This is the basic principle behind the operation of MARES diaphragm first stages. The diaphragm solution offers a number of advantages over piston mechanisms. Less friction when the valve opens and closes allows for more uniform airflows and improved performance in all situations. Further, all components and internal surfaces are completely insulated from the water. Operations are thus safer and more precise, ensuring longer and more consistent life than piston mechanisms.